Hello chemistry scholars, this video is to help you determine whether a molecule is polar or non-polar. Now, as you should remember from class, but just to give you a brief refresher, a polar molecule is a molecule that has an uneven distribution of electrons. While a non-polar molecule has an even distribution of electrons. So what that means is that in a non-polar molecule, you have electrons that are spread out evenly around all of the atoms, whereas in a polar molecule, one of the atoms is more electronegative and it pulls electrons towards one side of the molecule. That gives the molecule two different charges. Wherever electrons are pulled, you get a negative charge, and wherever electrons are pulled from, you have a positive charge. So in a polar molecule, you have two charges, whereas in a nonpolar molecule, you have an even distribution of electrons around all of the atoms of the molecule. So if you look down here by my 4 steps, you can see that to determine whether a molecule is polar or nonpolar, you need to do a couple of different things. Number 1, draw the EDD, which stands for electron dot diagrams. Number 2, you have to determine whether the bonds that connect the atoms to one another inside of the molecule are polar or nonpolar. And to do that, you're going to use these 2 charts that are down here at the bottom of the screen. Number 3, you need to draw the partial charges. So remember that if you have a polar covalent bond, that means that your electrons are going to be drawn to one atom, the more electronegative atom. And that means that the side of the molecule that that atom is on is going to have a partial negative charge. That's where the electrons are going to clump together. Now, the atom that has a lesser electronegativity value is going to have its electrons pulled away, which means that that side of the molecule would have a partial positive charge. That's where the electrons are taken from or pulled away from. So positive means that you have less electrons, while the partial negative charge means that you have an increase in the number of electrons around that atom. And then I'm going to show you finally, once you draw in your partial charges, if you can draw a line through the molecule that separates all of the partial negative charges from all of the partial positive charges, then that means that you have a polar molecule. But if you can't, that means that that molecule is non-polar. So why don't we start off with a couple of examples. The first example that I want to go through with you is water, or H2O. So let's take a look at our steps that are written over here in pink. Step number 1 says that you need to draw the electron dot diagram for water. So I have my oxygen that has 6 valence electrons, my first hydrogen that has 1 valence electron, and I have another hydrogen that has another valence electron. And if you connect the singletons to one another, you would see that this is the general form for water. But remember, water has these 2 unshared electron pairs, and that's going to cause the water molecule to bend. So this isn't entirely the correct electron dot diagram for water. Rather, I'm just going to erase it and draw the correct one for you as we learned in class. Here's your water with the 2 unshared electron pairs, and there are the 2 hydrogens. Okay, great. We did step number 1. Step number 2 are the bonds within the molecule, polar or nonpolar, and we need to use our charts. So that's what we're going to do down here. So we need to look at the bond between hydrogen and oxygen. So to determine whether this bond is polar or nonpolar, we need to look at our electronegativity values down here. We see that oxygen has an electronegativity value of 3.44, while hydrogen has an electronegativity value of 2.2. And if we subtract those from one another, we see that our electronegativity difference is 1.24. Now we have to look at the chart up here and see where the number 1.24 falls. Well, it's not less than 0.4, but it is between 0.4 and 2.1. Therefore, this bond here is polar covalent. So this is a polar bond, and so is this, because it's between the same two types of atoms. Okay, so great. We know that those are polar bonds, but what does that mean? Well, if you look down at your chart here for electronegativity values, we see that oxygen has a higher electronegativity value than hydrogen, which basically means that oxygen is going to pull electrons from each hydrogen toward itself. That means that oxygen, or the side of the molecule that has oxygen, is going to have a partial negative charge, because that's where all of the electrons are going. Meanwhile, the hydrogen side has a partial positive charge, because the electrons are being drawn from the hydrogen to the oxygen, because the oxygen is more electronegative. So we finished on step number 3. We drew in the partial charges. Finally, step number 4, if the molecule is polar, we can draw a line through the molecule that's going to separate all the partial negative charges from all of the partial positive charges. And if I just look at my molecule, I can see that that is able to be done. If I take a line and I draw it like so, I've separated all of my partial positives from all of my partial negative charges. That means that this side of the molecule is negative, while this side of the molecule is positive. We have a separation of charge. We have an uneven distribution of electrons. That means that water is polar. So that's how we determine whether a molecule is polar. But before I leave you, let's do another example. Let's do an example with carbon dioxide, which has the formula CO2. So if we look back at all of our different steps over here, our first step is to draw the electron dot diagram for carbon dioxide. So we have 1 carbon and 2 oxygens. And remember that the least abundant atom is always going to go in the center. So my carbon is going to go in the middle. And carbon has 4 valence electrons. And I'm going to have an oxygen on each side of my carbon. And remember that you have to pair up our single electrons, so we're going to have a double bond there between carbon and the oxygen on the left. We're also going to have a double bond between carbon and the oxygen on the right, but we can't just leave it like that. That's a pretty sloppy looking molecule. So instead, what I'm going to do is erase this whole thing, and I'm going to go ahead and redraw it. So I have carbon double bonded to oxygen on this side, and I have carbon double bonded to oxygen on the other side. Okay, great. So we have our electron dot diagram. We have finished step 1. Step number 2, are the bonds within the molecule polar or are they nonpolar? Well, we have to again look back at our electronegativity charts down here at the bottom. So I needed to erase all of my marks from our other problem. But here we're comparing carbon with oxygen. So we need to know, are these bonds polar or nonpolar? And are these bonds polar or nonpolar? So to do that, we're going to find the electronegativity difference between oxygen and carbon. Oxygen has a greater value, so that's 3.44, and we're going to subtract carbon's value, which is 2.55. Now, notice that I always am subtracting the lower number from the higher number. the electronegativity value always has to be a positive number, so it's always going to be arranged in that fashion. So as I do the subtraction here, here we go, 14 minus 5 is 9, and my 3 becomes a 2, and 13 minus 5 is 8. So my electronegativity difference is 0.89. And we see that, again, that falls here in between 0.4 and 2.1, which makes these bonds both polar covalent. So these are all polar. And what that means is that the atom with the greater electronegativity value is going to pull electrons toward it. Well, if we look back at our electronegativity value chart, we see that oxygen has a greater value of 3.44 than carbon's 2.55. So what's happening is that oxygen is pulling electrons from carbon, the same on this side. So if we assign our our partial charges, since each oxygen is pulling electrons toward it, that's going to make each side with oxygen a partial negative charge, and it makes our carbon in the center a partial positive charge. So let's look back at our list. We finished step 2. We just finished step 3, and now we have to look at step number 4. It says, if polar, you can draw a line through the molecule that separates all partial negative charges from all partial positive charges. Can we do that with this molecule? Well, let's try. If I draw a line like this, have I completely separated positives from negatives? No, I've split my positive charge in half. Can I do this? No, that's not going to work either. Because then, I have some of the negative and positive on the top, and I have some of each one on the bottom. In this case, we can't separate our partial negative from our partial positive. So carbon dioxide is a non-polar molecule. So use these notes to work on the assignment that I gave you and see if you can't determine whether the rest of those molecules are polar or nonpolar using this method. Thank you.